Let's proceed to lesson 7, the chemistry of the environment. We will go into tackle the Earth atmosphere. What is Earth atmosphere? Earth atmosphere is similar to a jacket for our planet. It's the surround our planet, keep us warm, give us oxygen to breathe, and it's where our planet happens. Earth atmosphere has 6 layers. First is troposphere, stratosphere, mesosphere, and thermosphere, ionosphere, and exosphere. Troposphere is the lowest layer of the Earth atmosphere. Stratosphere is the second lowest layer atmosphere Earth, located above the troposphere and below the mesosphere. Mesosphere lies between the thermosphere and stratosphere. Meso means middle, and this highest layer of atmosphere as which the gases are all mixed up rather than being layered by mass. Thermosphere lies between exosphere and mesosphere. Thermo means heat, and the temperature in this layer can be reached up to 4,000 degrees Fahrenheit. Ionosphere is a part of Earth's upper atmosphere, and X-ray solar radiation ionize the atom and molecules, thus creating a layer of electrons. The ionosphere is important because reflect and modified radio waves used for communication and navigation. Exosphere. This is the outermost layer, and the atmosphere is in this layer, atom molecules escape into the space and stabilize orbit the Earth. Let's move to human activities and Earth atmosphere. Human activities are the various action and reaction living necessity done by people. For instance, it includes leisure, entertainment, manufacturing and recreation, and war. Burning fossil fuels, cutting down the forest, and farming livestock are increasingly influencing and climate and the earth temperature. This adds enormous amounts of greenhouse gases to naturally occurring atmosphere, increasing the greenhouse effect of global warming. What is human activities affect atmosphere? Burning fossil fuels, releasing chemicals into the atmosphere, reducing the amount of forest cover, and rapid expansion of farming. Development and industrial activities are releasing carbon dioxide into the atmosphere and changing the balance of the climate system.
Earth water. What are Earth water? 71% of the Earth's surface is water cover, and the ocean holds about 86.5% of all Earth water. Water also exists in the air as water vapor in rivers and lakes. So this means that majority of Earth's surface is covered by water, which ocean making up the largest portion of it. Surface coverage 71% of Earth's surface is water, indicating that land makes up only about 29% of the surface. So the ocean holds 96.5% of Earth water, which means nearly all the water on Earth is salty and part of the ocean system. Only a small fraction of Earth water is fresh and found in places like rivers, lakes, and underground aquifers. Water is not only in liquid forms, it also exists as water vapor in the atmosphere and in smaller quantities in rivers, lakes, ice caps, and glaciers. Why is Earth water important? Every living thing in Earth requires water to survive. Water means different things to different people. The conversation on what in World Day Center on solving the global water and sanitation crisis, which will require everyone to do their part. So this emphasizes that water is essential for all forms of life, making it universal necessity. However, the meaning and value of water vary depending on the individual needs and context, ranging from personal consumption and agriculture to industrial and cultural uses. The mention of World Water Day is the global focus on addressing critical issues related to water access and sanitation. It undergoes that solving these challenges require collective effort with individual communities, government, an organization contributing in various ways to ensure sustainable and equitable water resource for all. The four types of water. First, groundwater. Second, flowing water. Third, standing water. Fourth, rainwater. So, groundwater. The groundwater absorbs water that retains in soil and the pores of rock. Water that has been absorbed in the ground is known as groundwater and it can be accessed via wells and boreholes. It is often relatively clean and very rich in minerals, which make it ideal if you need water for irrigation or watering your garden. It can also be filtered and used for outdoor cleaning. Flowing water. Water found in streams, rivers, and lakes with underwater currents be reasonably clean. The fact that water in these sources is constantly flowing or moving upstream prevents pollutants from building up. It may not be mineral rich as groundwater. This type of water can be cheap and easy to collect. Standing water. The term standing water refers to any body of water that is not flowing or in motion. Standing water can easily be stagnant, polluted, and unhealthy. So the term standing water describes water that remains still and does not flow, such as puddles, ponds, or water collected in containers. Because it is not moving, standing water can quickly become stagnant, making it breeding ground and for harmful bacteria, insects like mosquito and other pollutants. This lack of motion often leads to water quality deterioration, posing potential health risks to human, animals, and environment. Rainwater. It is significantly cleaner than standing water, but it may be deteriorated than flowing water or properly collected water, and it can be used for a number of different purposes. So this means that the rainwater is generally cleaner than standing water because it has not had time to accumulate contaminant like bacteria or debris from stagnant conditions. However, it may still contain impurities such as gas, pollutants from atmosphere, or contaminants from surface. It touches making it less clean and the flowing water are properly collected and treated content. Despite this, rainwater is a valuable resource and can be used for various purposes such as irrigation, cleaning, or even drinking if properly filtered and treated. So, how is water formed in the earth? According to Marbedele, the largest part of water comes from protoplanets formed in the outer asteroid belt that plunges towards the earth. Is indicated by the DH Pro portion in Chandrayaan point in the similar DH ratio as oceanic water. Human activities and earth water. Human activity such as burning of fossil fuels has an effect on the overall increase of the earth temperature. Raising the earth temperature means that there is an increase of evaporation, melting of land and sea ice, and impact of the other process of the water cycle that adversely affect the climate on earth. How do human activities affect water? Our water resource face as a host of serious threats, all of which are caused primarily by human activity. They include sedimentation, pollution, climate change, and deforestation, landscape changes, and urban growth. What human activities affect the earth, land, and water? Human activities are driving large-scale changes through land and sea use, the hunting and the harvesting of organisms, pollution, and invasive species introductions. The substance overuse of natural resources has caused unprecedented levels of environmental destruction, including the loss of ecosystem and biodiversity. How do human activities affect the flow of water? Humans impact the water cycle in several different ways, directly and indirectly. To start, humans are directly charged. The dynamics of the water cycle through direct manipulation. This includes the building dams for water storage and withdrawing water from lakes and rivers for industrial, agricultural, or domestic purposes.
So, good afternoon everyone. So, let's proceed to the topic 7.5, Earth Soil. Soil is the biologically active and porous medium that has developed in the uppermost layer of the earth crust. So, there are so many types of soils. So, why is soil important for the earth? Soil filters out waters, provide essential nutrients to our forest and crops, and helps regulate the earth temperature as well as many of important greenhouse gases. So there are four types of soil. First one is the loamy soil. Loamy soil is a blend of sand, silt, and clay combining the advantageous properties of each. It is considerable the fourth type of soil. So next one is the sandy soil, composed of small particles of weathered rocks. Sandy soil is the one of the least suitable soil for plant growth, of course, due to its low nutrients content and poor water retention, which limits the ability of plants' roots to absorb water. However, it excels in drainage and is often form the breakdown of rocks like granite, limestone, and quartz. Third one, silt soil. Silt soil contains smaller particles than sandy soil, made up of rocks and minerals fragments, known for its smooth and fine texture. It retains water better than sandy soil. Silt is often transported by flowing water and commonly found near rivers and the other types of body of waters. And lastly, we have clay soil. Clay soil has the smallest and most tightly packed particles, leaving little to no airspace. It has excellent water storage capacity but restricts air and moisture movement. When wet, clay feels sticky, and when it dry, it is smooth. As the densest and heaviest type of soil, it offers poor drainage and limited space for plant roots to grow. So, human activity and earth soil. Soil plays a crucial role in supporting human life, which often requires humans to manipulate and move it for various purposes. However, such action can result in environmental challenges or harm, including soil loss and degradation. Soil degradation refers to a natural or human-induced process that reduces the soil's ability to perform its function. So, how do human activities affects the soil? Therefore, as discussed, human can impact in two ways: through the negative processes of overgrazing and deforestation, as well as the positive processes of soil conservation and bearing farming practices. So the green chemistry, also known as sustainable or circular chemistry, focuses on designing products and practices that reduce or eliminate hazardous substances. Unlike the environmental chemistry, which studies the effects of pollutants, green chemistry aims to minimize environmental impact by reducing renewable resources use and preventing pollution. So what is meant by green chemistry? Green chemistry is the design of chemical products and processes that reduce or eliminate the generation of hazardous substances. What can green chemistry can be used for? Green chemistry has been used in a wide variety of products and practices, from the medical fields to computer technology to household paint and more. And what is the impact of green chemistry in our life? First is it can assist in reducing the costs associated in hazardous waste disposal. Second, green chemistry can benefit in the improvement of body and body and processes safely. And lastly, the impact of green chemistry on our lives is green chemistry can help in environmental protection by limiting the emission of harm compounds into the environment. So that's all the topic that we discussed. So thank you for listening and have a good day. Thank you.